Hey everyone, Dr. Calkins with week 8, chapter 18. This would be right before spring break if this were a 16-week class, or halfway through for an 8-week class. So in this chapter we're looking at the same kind of groups as we saw in week 7. These are called functional groups in particular. So there's two parts of this chapter, so there'll be two videos. There's synthetic polymers, which we're going to do now, and biological polymers, which we'll do in a separate video. Try to shorten them a little bit. So in synthetic polymers, there's two types. Synthetic just means man-made. Things we take for granted every day. And there's two types. So the first type is addition polymer. So addition polymer, just like the name implies, you're adding the same molecule to itself over and over again. So typically these are all alkenes, so let's just take the simplest alkene, which is got 4 hydrogens. We got a catalyst which allows these pair of electrons to add to another carbon that has 4 hydrogens. It can add to another carbon that has 2 hydrogens on each atom. And because this unit here is called ethene in our previous chapter, its old name was called ethylene. So that's its common name. Ethene is its IUPAC name. This will be added to another molecule because there's hundreds of thousands of these, and this would be added to eventually one as well. This process is taking monomers, so each one of these is a monomer, and linking them together into a polymer. So the monomer is ethene, 2 carbons. Ethene is the double bond. We saw that in our previous lecture over the week 7, chapter 17 stuff. But in week 8, chapter 18, what we're looking for is when you put these together, you now have the same little sequence of multiple carbons in a row, but we traded this double bond for this new single bond. This single bond goes off to somebody else, the single bond attached to somebody else. So what we have is this repeating unit that goes on forever. In our case here, we just have 2 hydrogens, so it's a saturated hydrocarbon chain. Same hydrogens that were up here, just giving them slightly better bond angles in their new tetrahedral format versus their trigonal planar format up there. So this, because it's now a polymer, we would say poly, zoom out a little bit, poly for polymer, ethylene. And there's two types, the Lcn Recycling Codes. You see the HDPE and the LDPE, that's just density based. We'll see that in week 13 chapter. High density just means there's lots of change in branches, and low density doesn't mean there's as many. So this is more of a more rigid milk jug kind of plastic. This would be more of a squirt bottle, flexible kind of plastic, like in hot glue guns and so forth. Easy to melt, easy to reform and so forth. So we can change a lot of things about polymers in these kinds of situations. If we were to use this one instead, so 2 carbons with the chlorine, this is called vinyl chloride, or chloroethene would be its IUPAC name. So this kind of gives it away, this vinyl group. We'll make the polymer vinyl, just replace one of these hydrogens with the chlorine. So in a polymer form, this would be poly vinyl chloride. Most people would recognize this as PVC, or just V for vinyl. So vinyl records, that kind of idea. Vinyl rain jackets or tarps, that kind of. A lot of saran wrap is made out of polyvinyl chloride as well. Other ones that are important would be ones with 4 fluorines. This is called tetrafluoroethene. So notice all these are ethene based because they're 2 carbon units with double bonds. So this one, when you make it a polymer and link it together in much the same way, just replace all these with fluorines instead, which are super electronegative, you would get poly tetrafluoroethene. So really all we're doing is adding the word poly. So this is called PTFE. So PTFE is Teflon. It's the white tape you put on threads on plumbing. It's also what you coat onto baking pans, cooking pans. And the reason it's non-stick is because you attach the most electronegative atom that shares with nobody. It's not going to share with your hamburger, your brownies, your cupcakes, anything else. very useful for DuPont when they coat lots of baking pans and so forth. A few more that are useful. Same kind of idea. If you have 3 carbons instead of 2, this would be propylene or propene. So you can make polypropylene, which is in a lot of playground ropes, usually the colorful ropes you see on swing sets and so forth. They're also used to make prescription bottles. So that very thick kind of orange plastic for prescription bottles is made out of polypropylene. A little bit more sturdier than this polyethylene version. It's going to have a recycling code of PP. Oops, wrong P. But regardless, it's just PP, so look for that recycling code. And then one more that's pretty common if we were using arene attached to, I think this is called styrene. If you link it together and replace one of those hydrogens with, instead of a methyl group, replace it with this arene, you get polystyrene. You add air to this, you get styrofoam, but this one's called PS, so this is in your red Solo cups, that kind of idea for polystyrene. One last idea to help with addition polymers is if you use multiple alkenes, even with branches, when you link these together, they're going to get a double bond in the middle. So imagine this idea. So here's your 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4. So as you link these together, now you're going to have between 2 and 3 a double bond, and between 2 and 3 a double bond. And because you have this alternating single and double bond, this gives you stretch. So this is how you make things like spandex. So that ability to stretch like that can give you spandex. It can also give you, say, rubber. So rubber bouncy balls, that kind of idea. Rubber elastic in your waist, your pants or shorts or whatever as well. So pretty unique that you can use shape to give you some stretch. And those are addition polymers, just lots of different types. The other major type of synthetic polymer is called a condensation polymer. So let's talk about those, and then this lecture is done. Condensation polymer, also man-made, but think of the word condense. Typically when we think condense, we think water, say on the grass as the sun goes down. So condensation polymers typically produce water. You'll make one of these in lab, or if you're watching the videos, you'll see me make one. But condensation polymers, there's really 2 types. You can take a amine, which is a group from our 14 from our last chapter, which is an amine, and then you can take a acid. I'm going to write these in a way to help out. So I'm going to move one of these hydrogens down. So notice in the middle right there, what we're going to steal is a water molecule. So here's your amine, here's your carboxylic acid. And what happens, notice that 2H and O that is lost in this condensation process, this piece and this piece now join together to make an R N C double bond O R. Still one of those hydrogens remains. That was this one here, that one there. Carbonyl remains, that one there. But now we would call this a amide. And amides are much like what we're going to see in the other part of this lecture. We would call those peptides if this were a amino acid. So condensation polymers are also very similar to what we see with our proteins. To make one amide is not a big deal, but to make several, we would call this a polyamide. And that would be things like nylon. So pantyhose, anchor ropes, that kind of thing, made from polyamides by taking 2 units instead of 1 over and over again. So here we have 1 unit repeats itself, then the other, then the other, then the other. So it's 2 units, kind of one after the other, instead of the same unit over and over and over again. And notice with addition polymers, all the atoms are accounted for. Down here with condensation polymers, we're losing a couple atoms in the form of water when it's typically boiled away in this kind of process. So you may not really know or care much about nylon unless you wore pantyhose. I actually know from experience, when I was a kid, my mom dressed me up as a spider, and 2 of the legs were my legs, and pantyhose, the other ones were with polyfill for Halloween. But in any case, we have another group that's very similar but different. We have an ROH, which is an alcohol from our previous chapter. We have again a carboxylic acid. Notice those H2O molecules in the middle again. So alcohol, carboxylic acid, repeat from before. When we take these pieces and we join them together, much like over here, we saw the polyamide. Now we have this RO and this C double bond OR. We would call this a ester. It's got the two groups. It's like the grandma's here pushing her little cart in the opposite direction. In this situation, making one's not a big deal, but making hundreds of thousands, we would call this a polyester. So this one's very important for clothing because these R groups are very hydrocarbon based. They're very long, very CH2 water unfriendly. Polyester is great for moisture wicking because these carbon oxygen bonds that are polar are outweighed by these very long chains that are non-polar, so they're going to hate water. Allow water to evaporate very quickly, so this keeps you cool in lots of sports where they have polyester uniforms and so forth. A lot of Nike, Under Armour, Adidas clothing use polyester for its wicking ability, which is very different from, say, cotton. Cotton has lots of OH groups, and in those OH groups, what we're going to see is a lot of water absorption. So cotton, very common to absorb water, used in towels, but you've probably never heard of a polyester towel because it hates water. It's not going to absorb water, and that's because it's not as polar as the groups that actually made it in the first place. Very common polyester, you'll find polyethylene terephthalate, PET. This is a soda bottle kind of plastic. It shows up with a recycling code much like those addition polymers from before. This one is actually a polyester that they use to make plastics for soda bottles and water bottles and so forth. So this is the major difference between synthetic polymers. We have ones that add themselves together over and over and over again, or we have two molecules that add itself together over and over again, and those are condensation polymers. So two types that are man-made, both which are useful. Use them every day. So we'll catch you next time with biological polymers.